Hello, and welcome to PRChomps, episode 15. We are going to do a special episode. It's the 15th episode. I decided I wanted to do something different. It's my show. I can do what I want. And I'm going to talk about space and physics and philosophy with one of the most respected minds in the Minifan community. I'm joined today with none other than Biodude, and welcome.
Well, thank you very much. I guess I am amongst some people respected, at least, and amongst others, probably not so much. But
Give yourself more credit. I think everybody respects you. Respects your mind. So, all right. So, like I said, this is going to be there's no food this time, or maybe we'll get to food. Who knows where this will go? But we're just going to talk some space. We're going to talk space and time and all that. And I thought there would be no better place to start than the Fermi paradox. And for those that are unfamiliar with the Fermi paradox, it basically is if there's seemingly an infinite number of galaxies, there's trillions upon trillions and trillions and trillions of galaxies. They all have their stars, and then there's trillions and trillions and trillions of planets in those galaxies. How come there is no real tangible evidence of aliens? How come they haven't visited Earth? How come we haven't come face to face? Why are they not?
Just life in general, the Drake equation as well. Where is it all? I think what it comes down to is, at least part of it is like the fine structure constant. There's only certain areas in the universe that can support life. And we lucked out. We're in one of those areas that can support life. I think, though, more to the point, actually, for me, I'm really coming to believe that we're in a simulation. There are things that we can't be explained. Let's just start there. Quantum entanglement, and how let's say two quarks that get entangled, or two atoms, they can quantum entangle atoms or photons. There we go. Let's do that. Mm-hmm. They can quantum entangle photons that are from like galaxies billions of light years away, and they will instantly change states. How is that happening? It's happening faster than the speed of light. My sort of what I'm coming to build my own philosophy on, or my own thought process on, is I don't think the speed of light is the fastest thing, and I don't know that we really know what the speed of light is, because in testing the speed of light, what we actually do is I'm trying to explain.
Yeah.
So we take the number that we have, and we get that number by dividing it by 2. I wish I could explain it better. I've heard it explained better. But at the end of the day, with what I'm talking about here, there's something, dark matter, and there's something else going on that nobody understands. And I kind of feel like what makes the most sense is if we were just in a computer simulation, like really good one.
I actually agree with you on that point as well about the simulation, and that would kind of
poorly, but
it would kind of give an answer to the Fermi paradox about why we're not visiting other life form or mm-hmm. other life forms and other like that, because we're basically being watched. We're like a saved game of The Sims from like 50 years ago that they just decided to play, and we're just kind of playing out.
Yeah, I think somewhere way in the future, there are people that are trying to figure out how they got to where they are. And what they're doing is running simulations over and over again.
Well, yeah, because that's the easy. I mean, the best way to predict the future is to study the historical data from the past.
Mm-hmm.
So it would seem to, like, logic would dictate that if, like, if they want to figure out where they went wrong, or how to get themselves out of something, that they could watch us evolve as a civilization to kind of learn objective data about how we fucked up.
I wish I could explain better what I'm trying to say about this, like, faster than the speed of light sort of stuff. Like, maybe we could just talk about the fact that astronomers, what they observe when they look at the galaxies is that they should be flinging apart, but they're not. There's something more than gravity that's holding them together. And so they call it dark matter right now,
Mm-hmm.
right? Or it's a program. And in the program, they just set things. They set, like, definitions, like, this is the speed of light, this is the speed of sound, this is the speed of whatever. If it's not that, then there's this untapped energy that we need to figure out as well. Like, so if we're not in a simulation, then there is this, like, unbelievable amount of energy out there. Something is holding these universes together, is holding everything together, and it's not the gravity that we see. That only accounts for like 30% of what's doing it, so to speak.
So the interesting theory about that the scientists, because actually dark matter is kind of like, it's kind of fading away, like in the newer scientific circles and stuff. They're kind of their biggest thing, and now I'll jump back to what you were talking about with quantum entanglement and all that stuff, is like you were saying, like when you look at in space, if you look up at the sky and stuff, everything looks neat and orderly and just almost like a painting. But the more you zoom in on life, and I'm talking like past atoms, beyond that, the more chaotic and just fucked up it all is.
Yeah, it's all probability. Once you get down to the quantum level, they can't like put a finger on exactly where any of that stuff is.
Yeah,
these little quarks, these things spinning around. They found the Higgs boson particle quark.
Yeah.
They're looking for things like a gravity molecule. I tend to think that if there is some type of gravity molecule, it's damn tiny. Like, it's going to be hard to find. I heard a theory recently about gravity being an emergent what's the word for it? Emergent gravity. Where, now let me try and explain this one. Emergence is the word we use to describe sort of the boundary of two sciences, almost, or two, like, where chemistry meets physics. How we figure out how these atoms are combined together, or pressure. Oh, that's an even better way. Like temperature and things like that. How we define temperature. It's something that we feel, but, like, if you measure it an atom, it's not going to give you, like, a temperature. It's all of them working together. And when all of these atoms working together in your room, all of a sudden, not all of a sudden, but what emerges is temperature. It's there's people that are thinking that that's what gravity is. Here, I got a great way to explain this. You ever see an ant just running around all by himself, right?
Mm-hmm.
Just going everywhere. Well, when you get a bunch of ants together, like in a colony and stuff, they start doing things like, I've seen them build bridges, but they're not talking to each other This is just something that they know how to do, because when they're together in a giant group, that's what emerges out of it. There are people that think that life itself, us, what we're doing right now, is the emergence of from gravity.
That's interesting.
Yeah, I'll try and refine that. I'll think about it, try and explain it a little bit better. But I like that idea. I like it better than the idea that there's a quark, a gravity quark or anti-quark.
So let me ask you something. So when you use the ants in your example, and alone, they just kind of, they don't have a place. They're just kind of
running around, maybe
roaming around doing it.
Whatever. But
once they recognize another ant or multiple ants, they know that it's time to work, or they know what to do.
Mm-hmm.
So how would that apply to the particles, molecules? It almost implies that they have some kind of sentient existence of some sort.
Well, that's a great point. And actually, I'm leaning towards the idea that everything has something of a conscience, not like a conscience like we have, but I heard it explained. It really sounds crazy to jump right into that, like everything has a conscience. But if people thought that way, just in general, just back it up here for a second. If people thought that way, the world would be a better place. If like everybody would treat everything better. But that's exactly what comes of it. Like the ants or air or anything else. But I'm failing to describe it as well as I had hoped.
No, but I get what you're saying, and that kind of brings up an interesting point, like almost to our death, our biological death. Would we have a sentient? Would our energy have like a sentient experience after death, even though we can't express it, even though we can't?
Well, okay. Here's the thing: where is conscience? Where does that? Does it arise in our brain? Like you can take parts of your brain away, and you still have a conscience. You still are somebody. You might lose some memories, but you don't lose the fact that like you are a person. And what I've heard is that people believe that it happens at the quantum level. And I've actually thought that it could be happening. Not only is it happening at the quantum level, but it could be as simple as a single photon. Like one photon could have the conscience. I don't know. Or like we're talking about this emergence factor, when you get so many like in your brain together, all of a sudden conscience emerges.
That's interesting. Now that would be like, this is just a very roundabout kind of way, but imagine, you know how people have, oh, I was this in a past life, or I swear I was this in a past life, or like if we expounded upon that theory, that would kind of, explain why people have those intuitions and those feelings and stuff like that. Because I'm talking about when you die, maybe your energy goes out and has a conscious, but your energy can neither be created nor destroyed. So it was there before your existence, even though it wasn't you. The parts of you were still there.
In what we know for a fact, what we know for a fact is quantum entanglement is real. So it sounds silly, it sounds impossible, but if you get two photons entangled with each other, they instantaneously know each other's state, no matter how far apart you separate them. I heard somebody say once, it's almost like, it was Einstein, right? And he said it's like they had to make an agreement. They had to like make an agreement beforehand that this was going to happen, but then they also have to know instantly that it's happening. That's I think you can extrapolate that out to, like you're talking about, sort of.
That would explain a lot of stuff, like the
It's a,
soul, for instance. Yeah,
I'm sorry, what was that last thing?
Oh, I was gonna say that, like, that would explain the soul. You know what I'm saying?
Yeah, I mean, I do. I think about this stuff. I think about this stuff quite a bit.
Me too.
I was raised very. I was raised in a very standard kind of Christian Baptist. But as I get older, I'm sort of getting away from that. And what I'm filling that sort of hole with, I go to church every Sunday still, but what I'm filling that hole with is sort of this sort of, it's it's almost mystical to me. Um, some of this stuff, some of this quantum stuff, so to speak.
Is that like your primary focus right now? Is like the quantum parts of space?
Yeah, I would say that as far as space goes, I would say how it interacts, how these things on these giant scale act the same way as these things on this on the quantum level. It's it's just everything in between that seems to have a little bit more definition. Like everything feels hard, but when you start to sort of hammer down, like we're talking about probability and talking about not being able to sort of see where everything is. Here, I got a great way to start this might help me get more on track too. Let's talk about the like wave particle and the double slit experiment.
Mm-hmm.
So what they were using photon. Eventually, they started using photons. They figured this out a long time ago, with with light and I don't know what else, but photons in general. They were shooting photons through a slit, right?
Yeah.
And you would expect those photons on the other side. There's like a mat. It would hit the mat and shooting them through the slit. You would expect them to show up like this: boom, boom, boom. Then you put two slits in, and they're shooting these photons through these two slits. So it's like shooting light. You can actually do the test, I think, with just light, even it'll do it. And what appears isn't two slits, it's a wave pattern, what would look like a wave pattern. So for a long time, they were trying to figure that out. They said, okay, well, light is a wave, so that's why it acts that way. Eventually, they were able to do just one photon at a time. And when they started shooting just one photon at a time, it still was doing this wave thing. So then they decided, well, let's put some sensors on this and let's watch which slit they come out of. Let's try and follow these photons, so to speak. As soon as they did that, they stopped. They stopped making the wave pattern and they started making a photon pattern or like a two slits, like they were going through two slits. It's called the observer problem, I think, observer something. And it's sort of where quantum physics began, I would say.
Mm-hmm.
So why do I bring this up? What's going on here? Well, essentially what this means is that these photons are going there every possible position. I don't know. I don't know. I'm sorry.
You're
I've lost
fine.
a thought. I
Yeah.
I guess I get nervous when I'm
No, man, you're totally fine. It's almost like a Schrodinger's cat situation.
Well, yeah, right, right. If you until you open the box, you don't know if the cat's dead or alive. So he's in both states.
Mm-hmm.
I wish I could explain that one better too. I'm absolutely at a loss for why I can't explain myself nearly as good as I normally can.
No, that's totally fine. But no, I was thinking about the speed of light thing you were talking about too, which would go back to your simulation point you were making. Like that, what would be the best way to like prevent us from knowing the answers to the simulation or getting out there and exploring the truth is basically impose that speed limit would make it and the sheer size of the universe to make it so it's like we can't. You know, you need an infinite amount of mass to go the speed of light. We just don't have that much mass and energy.
It's interesting, you know. I'm sure the tests they did with the atomic clocks where they put them on the plane, they fly them two different directions, and when they get back, I mean, they should be the identical time, but when they get back, they're off.
Yeah.
Because, this is just sort of explaining, Einstein's theories of relativity and, well, relativity. Time is relative to the person. Um,
But it almost puts like the power in our. I mean, if everything is relative to the observer, then the observer is the most necessary part of all existence in life.
which is why I come back to the fact that I think it's a simulation. Like, I mean, like, there's no great answer for any of it, but the fact that, like, once you observe any of these experiments, you change the experiments. It just means something to me. I guess I haven't really figured out exactly what it means, but something for sure.
It means someone's trying to keep the wool over our eyes, in my opinion.
Well, it's like that fine structure constant I was talking about. That's what it's the value that electromagnetism holds over the atom and the nucleus and that spins around it, how it holds it together. It's If it was a little bit one direction or a little bit the other direction, we wouldn't have chemistry. We wouldn't be able to split atoms or separate them, or they would just all fly apart. And
But that kind of equates to like just all the necessary variables that had to be 100% correct just for life to exist on Earth, just for
right,
Earth to exist.
that's my point. I mean, that's exactly it. And it's
Yeah.
like, it's I mean, like, it's as easy for me to say that it's God that did it as it is for me to say that it's a simulation. But what I just can't abide by is that it's just randomness of nature. I mean, of randomness of everything. I just don't see that. I see um, Penrose, like, he talks about he talks about God. No, he doesn't. He talks about a maker for the universe, but he's very atheist or very against it being a god. Yet he's saying that, like, the conditions at the start of our universe had to be so precise to get our universe to work right. Um, I think it's easier to believe in a god than to think that it was just from an explosion.
And if you have an explosion, you need TNT. You need gunpowder. You need, but I guess that's my point. Is I guess just as much as I try to rack my brain, I can't get. I can't. Maybe it's because I'm just human, and humans are stupid. But it's like it's very hard to grasp the scientific concept of nothing.
Yeah.
And how it could all come from nothing. because when you think of it in a human perspective, nothing is nothing. But in a scientific perspective, nothing is something.
It's interesting that we spend so much time trying to figure out what was at the start. I was listening to something recently. They say the Big Bang, then they think at the very start Big Bang, then right after that there's this super expansion. Where did it all come from? Heat and gravity and pressure, but where did any of it come from? At the end of the day, it'd be like, I don't know.
Where did the forces come from? If there's nothing, then right. how could all that stuff that isn't even a thing technically according to scientists exist if there isn't even an arena for it to exist in? I guess
that's what. So for me, that's why I like the idea of a simulation where we're being spun up to figure it out, right? Like we're thinking about it at least, and it just doesn't make sense that, like the Fermi's paradox, it just doesn't make sense that there's just nothing else out there and we can't see it. That it almost seems like a trick.
Yeah. But at the same time, I can kind of see the counter arguments is like the reason that nothing is out there could be just because if you look at us, like how much longer do humans have on Earth before we destroy it and it's gone and all that stuff. And it's like I've always had this theory that Venus was Earth before us.
And then it just got
it just went to hell in a handbasket and then runaway green. I mean, and I don't want to start like a climate change thing or get political, but I'm saying like it's very possible for us to destroy the Earth and create a runaway and turn Earth into Venus. You know,
very much so. Well, the same thing with Mars too. Like I think 10,000, 20,000, 40,000, 50,000, 100,000 years ago. Like why is there nothing on Mars? Like why is there all this water here? And I understand it's a little bit smaller. It doesn't have the electromagnetic field to protect it from radiation, but it is, Elon Musk wants to terraform it. If we could do that, then at some point in the past, it stands to reason, for me at least, that there should be something there. Like those Curiosity rovers and things like that should have found something.
You would think so, but I don't know. Like, why do we spend so much time? And you may be able to answer this better than I can. Why do we spend so much time trying to go to different planets to see if it's habitable, and not as much time trying to like go underground?
Mm-hmm.
It seems like it's a lot closer than Mars would be.
Yeah, and there's plenty of stuff to explore here, and it's as equally unknown, the deep sea, as outer spaces, and it's right here. I think because when you go outside at night and you look up in the sky, up in the sky, and you see all the stars and stuff, my natural inclination is to say like there's got to be something up there.
I mean, there probably is. I mean, I hate even saying that because there probably might not be. Like, it's just so weird because we could just they could even be so advanced they exist in a dimension that we can't even see. They could be among us right now. We just don't even know.
Well, I like that. I like that thought a lot, actually. That like multi-dimensional kind of things. I was these sort of the UFOs that we've been that the military, like the three that came out, the Tic Tac, and there's two other ones, but the way that they're just these like little balls, and they move like faster than whatever. Like, I like the idea that these things could be interdimensional. It's easier to think about like a two-dimensional creature seeing a three-dimensional thing. Like, we watch TV. That's TV is two dimensions, but our minds can accept that it's happening in three dimensions. So like a two-dimensional creature could see a three-dimensional TV, could see something on a three-dimensional TV and sort of get their head around it. I would like to get my head around four dimensions a little bit better.
Now they say the fourth dimension is time.
No, not really. Like, so I mean, I sometimes they do say that, and maybe I'll be proven wrong, but like I said, I'd like to get my head around it a little bit better. But
did he freeze? Oh no,
it's hard. They do say it's time, but it's not time. It's not. It's like.
But when you go into a black hole, then time becomes space, and time physically alters space and everything like that. So it has more of a dimensional aspect in that arena.
Well, there's a physical aspect to it that isn't the time. Like, have you ever seen like, oh yeah, like what's that thing in the not the X-Men, in like Thor, that cube, whatever that.
Oh, the Tesseract.
The Tesseract. That's a four-dimensional cube.
Well,
that's supposed to be.
It's supposed to be, but it's we only live in a three-dimensional world.
Right. It's as close as we're gonna get to it.
Yeah,
I've seen some animated versions of that thing, which are kind of cool, where it just sort of folds in on itself.
Yeah, but I think the only thing I don't like about the like Tesseract is like the only way they explain the fourth dimension is in a third physical like dimension type deal, and it's like, I'd like it to be more metaphysical.
Well, that's my point though, is that I kind of feel like I was saying before, maybe we could never experience other dimensions, but I think a two-dimensional creature could see three dimensions. They could see it because we watch TV, and TV is two dimensions, but it's giving us the illusion of three dimensions. So I would like to figure out a way to get. I mean, I would like to be able to see other dimensions, and I feel like that's possible.
Now, yeah, but the only problem I have with that is when you look at the TV and you can see the illusion of three dimensions, but you already have a physical concept of the third dimension.
Well, that's exactly it, right? So that's why. But that being said, I think the way I think about it is I go back to a two-dimensional creature, and if I was trying to talk to a two-dimensional creature, I would say something like, okay, this isn't a square. This is what we call a box. This box is like a square, but it has more sides or something. I don't know.
Yeah. A really smart two-dimensional creature maybe could figure it out.
They have this. I've never been able to find it, but I saw a program for like the VR that lets you sort of play with four-dimensional objects.
Oh no shit!
Yeah. And like I said, I've never been able to actually find it, but it was something to sort of help you get your head around it. And they have that bottle. Have you ever seen that? I don't know the name of it, unfortunately, but it's a four-dimensional bottle. Somebody's
vase or something.
Yeah, exactly. Yeah, right. Because because it's like it turns in on itself, and I mean, I've seen like real ones in 3 dimensions.
Yeah. What is that base called? It's like somebody's jar or something.
So
Klein bottle.
Klein bottle. That's it.
Yep.
That's exactly it.
Yep.
Yeah. So if you can do the math and you can mock up a 4-dimensional bottle, then like I think I can get my head around it someday.
I think that'd be cool. I mean, I would love to get my head around it. I just don't know if my head could get around it, but I would love to get my head around it.
I got another one that's kind of interesting to me, at least. But have you ever played with holograms, like real holograms, like they shine them and it, like?
Yeah, like cursory, not a whole lot.
Well, there's a couple really cool things about them, and I wish if I had thought about it, I'd pull up some images that we could show. But when it's to take a picture to make a hologram, like everything has to be really still. You shoot, it's a laser, and you split the laser beam, and it goes through this material that makes the hologram. Once you have that hologram, there's 2 things that I find just amazing. There's a picture online that you can find of a hologram of a microscope, just a regular microscope sitting on a table, right?
Uh-huh.
If you angle it right so that you can look down the eyepiece of the microscope, you can look all the way down the microscope at what was on the slide.
Really?
That's pretty cool. The other thing that's really neat about a hologram, right, is if you cut off a piece of it, like if you punched a hole in the side of it and you pulled that piece out, that's the whole hologram again.
Really?
Yeah. There's so much
cool.
information encoded in these holograms. And I bring this up because that's another thing people think is that we live in a holographic universe. I'm sure you've heard of that before.
That would be a lot like the simulation, though.
Right. Yeah, exactly. That's why I brought it up. It's all part of the same stuff that sort of I kick around in my head quite a bit.
Huh.
I will show you. I will send you. And if this ever gets put out on air or anything,
It will.
Okay. Well, then I'll send you the picture I'm talking about of the microscope, because it really it's really mind blowing. And the other part of it, where you'll just have to believe me, if you just punch a little piece out, that little piece is that whole image.
That is nuts. I got to look into holograms more. I'll admit I didn't give holograms the respect they apparently deserve.
Absolutely. I'm not kidding. It'll blow your mind. Both of those things. The fact that you can sort of angle this flat piece of paper and look down the barrel of the microscope and see what the slide that was on there and whatever the microorganism that was on there, so to speak, is amazing to me. And then the fact that like a little piece taken off of that picture becomes that picture again.
That's the cool part. That's crazy to me. Right. Well, cool, man. So that's our star talk, I guess. I know you got some golf to get going to, and it is close to my bedtime. So
okay. Well, listen. I feel like I was a little scatterbrained this time. I had a lot of fun, and I'd like to like think it out and give you an even better a better chat sometime.
Okay. Yeah. Let's come back. Trying to think, maybe like the 25th episode or something, or the 30th, or like kind of.
Yeah.
These specials, we'll do them every once in a while. But no, I really enjoyed this as well, so I'd like to do it again too.
Yeah. I thank you, and as much as it might not have sounded like this is one of my favorite subjects, it actually is.
No, it was cool, and I could tell when we got into holograms that was something that really like interested you. So maybe I will do some more research on my end so we can have a better discussion about it next time too.
Yeah, and like I think I think I'll put a little outline together too.
Okay.
So it's a little. I'm not all over the board, but I really appreciate your time. Thank you.
Yeah, no, this is awesome, man. So thank you very much. And that's PRChomps episode 15.